Okay, ready to dive into some algebra?
Sounds good to me.
It can feel like learning a whole new language sometimes, right?
Absolutely. It's like you're building a house, and all these basic concepts are the bricks and mortar. That strong base is crucial.
So, no shaky foundations here. We're going to unpack a lesson on the foundations of algebra and see how those simple concepts can unlock some seriously complex math later on.
Sometimes the simplest things are the most powerful, that's for sure.
All right, let's start with variables. I remember when I first learned about them, I was like, wait, letters in math? That was a little mind-blowing.
It can seem a little strange at first, but think of variables like containers that hold unknown numbers.
Okay, I get that.
The lesson has a good example with imagine a store where the price of bananas changes all the time. Instead of writing out the price each day, they could just use the variable b to represent the price.
So B could be like 50 cents one day, 75 cents the next.
Exactly. That's what makes them so powerful. Instead of getting bogged down in specific numbers, variables let us generalize math ideas. So when we learn a rule using variables, it applies to tons of different situations, not just one specific problem.
So variables are like those adjustable wrenches, huh? They can fit lots of different sizes of nuts and bolts.
I like that analogy. And once we have variables, we can start putting them together with numbers and operations to create expressions. It's like forming sentences in algebra.
So if variables are the words, expressions are like putting those words together to make phrases.
Exactly. Like, let's take the expression 2x plus 5. Yeah. 2 is our coefficient. It tells us how many x's we have. The x is our variable, and then the 5 is our constant. It's just a mathematical phrase.
Right. It's not a full problem to solve yet. It's like saying 2 bananas plus 5 apples. It doesn't tell us what to do with those fruits, just that we have them.
That's a great way to think about it. Now, if we want to actually do something with these expressions, we need to understand the order of operations.
PEMDAS, parentheses, exponents, multiplication and division, addition and subtraction. But to be honest, I never really understood why we had to follow that specific order.
That's a really good point. It's not just about memorizing a rule, it's about making sure everyone solves expressions the same way to avoid confusion. Like, imagine if we all built houses without blueprints. Nothing would fit together. So PEMDAS provides that blueprint for math.
Okay, I'm starting to see it. So PEMDAS is like a set of traffic lights for math, making sure everything flows smoothly and we all get to the same answer in the end.
Exactly. Let's say we have the problem 2 plus 3x, 5, 2, 2. PEMDAS tells us to start with those parentheses first.
So first we solve 5, 2 inside those parentheses, which gives us 3. Then we'd square that 3 to get 9.
You got it. Now we have 2 plus 3 by 9, and multiplication comes before addition. So we get 2 plus 27, which equals 29.
I see. Without PEMDAS, you might try to add the 2 and 3 first, then multiply by 9 and get a totally different answer.
Exactly. And that's why it's so important, even outside of math class. Imagine writing a computer program. If the code doesn't follow PEMDAS, it could lead to all sorts of errors.
It's not just about getting the right answer on a test, then. It's about understanding the logic behind the rules so we can apply them in real life.
That's a perfect analogy. And speaking of rules, let's move on to another important set of guidelines, the properties of real numbers. They're like the grammar of math, the underlying principles that govern how numbers interact.
All right, what are some of these grammar rules we need to know?
Well, one important one is the commutative property, which basically says that for addition and multiplication, the order doesn't matter. So 2 plus 3 is the same as 3 plus 2. 2 by 3 is the same as 3 by 2.
Yeah, that makes sense. But I guess having a name for it and understanding why it works helps us apply it to more complex situations, huh?
Exactly. It might seem obvious, but imagine trying to explain this concept without the commutative property. It'd be like trying to describe a color without having a word for it.
I see what you mean. So what other properties should we know about?
Another key one is the associative property. This one tells us that for addition and multiplication, the way we group numbers doesn't change the outcome. So 2 plus 3 plus 4 is the same as 2 plus 3 plus 4.
Okay, so it's like rearranging ingredients in a recipe. You might mix them in a different order, but the final dish should taste the same.
Exactly. And finally, we have the distributive property, which is really useful for simplifying expressions. It says that when you multiply a number outside parentheses by a sum inside the parentheses, you can distribute that multiplication to each term inside.
Can we see an example of that? I'm getting some high school math flashbacks here.
Absolutely. Let's say we have the expression 2, 3 plus 4. Instead of adding 3 plus 4 first, then multiplying by 2, we can use the distributive property. So 2 multiplied by 3, which is 6, plus 2 multiplied by 4, which is 8, and 6 plus 8 equals 14, which is the same answer we'd get if we added inside the parentheses first.
Okay, I'm seeing how that works. We're basically breaking down the problem into smaller, easier pieces.
That's a great way to put it. And these properties, commutative, associative, and distributive, are essential tools for working with expressions and equations. They're like having a well-stocked toolbox. The more comfortable you are with each tool, the easier it is to tackle any repair job.
So we've covered variables, expressions, order of operations, and properties of real numbers. That's a lot.
It is, but remember, these are the fundamental building blocks. Once you understand these, everything else in algebra will start to make a lot more sense.
It's like learning the alphabet before you can read, right?
Exactly. And speaking of reading, I think it's time to move on to the next chapter in our algebra adventure. Simplifying expressions and solving equations.
All right, so we've laid the groundwork. Now it's time to build something, right?
Exactly. Time to look at how to simplify expressions and solve equations, the real heart of algebra.
I remember feeling a bit lost with this stuff in school, like, when will I ever actually use this?
I think a lot of people feel that way. It's easy to get caught up in the symbols and rules and miss the bigger picture, but the truth is, algebra's all around us, even if we don't always realize it.
Okay, give me an example.
Well, just think about going to the grocery store. You want to buy 5 apples, and they're on sale for, like, 75 cents each.
Yeah.
You could add 75 cents to itself 5 times, but that takes a while. Algebra gives us a faster way.
Multiplication.
Right. We can use the expression 5a, where a represents the price of 1 apple.
So 5 times 75 cents, which is what, $3.75?
Exactly. See, algebra simplifies things.
Okay, but what about something a little more complex?
Let's say you're planning a road trip. You know the distance and your average speed, but you need to figure out how long it'll take.
Distance equals speed multiplied by time.
You got it.
Right.
That's an equation that describes how those 3 variables relate. And with algebra, we can rearrange it to solve for time. Time equals distance divided by speed.
So like if I'm driving 300 miles and my speed is 60 miles an hour, the trip will take me 5 hours.
Exactly. And this is just one way algebra can model and solve stuff in the real world. Once you get the basic concepts, you can use them for all kinds of things. Budgeting, designing stuff, you name it.
Okay, I see how those symbols and rules can be pretty handy.
Yeah.
But let's go back to expressions and equations for a sec. What's the difference between simplifying and solving?
Simplifying an expression just means making it as clean and short as possible. It's like organizing your room. You don't change what's there, just make it neater.
And solving an equation is more like finding a specific answer, right?
Yeah. An equation has an equal sign, which means we're trying to find the value that makes both sides equal, like a puzzle where you got to find the missing piece.
Okay, so simplifying is tidying up, and solving is finding that missing puzzle piece.
Perfect. Let's look at some examples from the lesson. First, simplifying. We've got 3x plus 2 by 5. Notice we have 2 terms with the same variable x. We can combine those, so 3x plus 2x equals 5x.
So the simplified expression is 5 by 5. Much simpler.
Exactly, and that's the goal. Make it as compact as we can. Now let's try solving an equation. The lesson gives us 4 by 7 equals 13. Our goal is to isolate the x, get it alone on one side.
How do we do that?
We use the properties of equality. Whatever we do to one side of the equation, we got to do to the other to keep things balanced. Here, we start by adding 7 to both sides, so that gives us 4x equals 20.
Got it. And then divide both sides by 4 to get x by itself. So x equals 5.
You nailed it. Solving equations is about using those steps and properties to uncover the value of the variable. It's like being a detective. You gather clues to find the answer.
So we've talked about simplifying and solving, but this is just the beginning, right?
Oh, yeah, there's a whole lot more to algebra, but these basic ideas are the foundation for everything else. Once you get these, you can handle tougher stuff with confidence.
Like learning to walk before you run.
That's it. And speaking of running, how about we move on and see how algebra connects to other parts of math and to the real world?
So we've built our algebra foundation. What can we actually make with it?
Now we can see the bigger picture, how algebra connects to other areas of math and the real world.
I have to admit, when I was learning this, it felt kind of abstract. Like, how does it actually apply to my life?
Lots of students feel that way. It's easy to get caught up in the mechanics and miss the connections, but algebra is everywhere, trust me.
All right, convince me. Where do we see it outside of textbook?
Well, think about music. The relationships between notes and rhythms can be expressed using ratios and patterns.
Which are algebra concepts.
Exactly. Even if you're not a math whiz, understanding algebra can help you appreciate music more.
Okay, interesting.
Or what about sports? You can use algebra to analyze player stats, calculate batting averages, even predict things like the path of a basketball.
So those equations become more relevant when you apply them to something you like.
Exactly. And then there's personal finance. Algebra can help you budget, figure out interest rates, plan your savings.
Okay, now you're speaking my language.
Right. And honestly, the more you explore different fields, the more you'll see algebra is a tool for understanding and solving problems. All kinds of problems.
Like a universal language.
That's a great way to put it. And as you keep going with math, you'll find algebra is just the start. It leads to things like calculus, statistics, even computer science.
So it's the first step on a much bigger journey.
It is. And the best part is, the skills you build in algebra, critical thinking, problem solving, will help you no matter what you do in life.
So even if you don't want to be a mathematician, algebra is still worth learning.
Absolutely. And it's a journey, not a race. You'll have challenges, but you'll also have those aha moments where it all clicks.
And those moments make it all worthwhile.
For sure. So, to anyone out there starting with algebra, my advice is embrace the challenge, stay curious, and don't be afraid to ask questions.
And there's lots of help out there. Teachers, tutors, online stuff.
Right. And most importantly, celebrate your wins. Every time you get a concept or solve a tricky problem, take a moment to appreciate what you've learned.
That's great advice. Maybe you'll even discover you love math.
That'd be awesome.
Well, that wraps up our deep dive into algebra. We hope you've gained a new appreciation for this subject.
And remember, the learning doesn't stop here. Keep exploring, keep asking questions, keep pushing yourselves.
Thanks for joining us on this adventure. Until next time, keep diving deep.